All right, let's talk about a huge shift that's happening in AI. This isn't just about AI that can, answer a question or make a cool picture anymore. We are stepping into the age of agentic AI. These are systems that can actually do things, make their own decisions, take actions, and operate all by themselves in the digital world. And with all that incredible new power comes a really urgent new problem. How in the world do we keep it secure?
I mean, really think about that for a second. If you spun up an AI agent right now, one to manage your company's finances or maybe run your entire customer service department, could you be absolutely sure it's safe? Could you trust it not to be hijacked or manipulated or even subtly turned against you? This isn't some sci-fi scenario anymore. It's the core challenge that developers and security pros are wrestling with as we speak.
But look, before we can even think about a solution, we have to get our heads around just how different this new world is. We are in the middle of a massive change, moving away from predictable apps and into what people are calling the new agentic era. And it really does change everything.
Okay, let's break this down, because this comparison is at the heart of the whole problem. On the left, you've got traditional software. It works on defined rules. You click a button, a very predictable thing happens. A human is always in the driver's seat. But agentic AI? It's a completely different beast. It's autonomous. It acts on its own. It's constantly learning and adapting. And here's the real kicker. Its actions can be unpredictable. And that's why our old security playbooks just aren't going to cut it.
So why exactly do our trusted, time-tested security methods fall apart here? Let's get into the diagnosis. It's not that they're totally useless, it's that they were built for a different kind of world. And they have these giant blind spots when you point them at an autonomous AI.
This is where the cracks really start to show. Classic security frameworks like Stride or Pasta, they just weren't built for these four issues. They have no way to model the sheer unpredictability of an agent whose goals might get twisted. They have no real playbook for these weird adversarial ML attacks that only exist in the AI world. They don't consider a future where multiple AIs could team up against you, and they don't fully get the risk that the AI model you downloaded might have been compromised from the get-go.
So, with the problem laid out bare, we obviously need a new playbook, one that's actually designed for this new reality. And that's where a framework from the Cloud Security Alliance comes into play. It's a playbook built from the ground up to handle the unique threats of agentic AI, and it's called Maestro.
So Maestro is an acronym, and it stands for Multi-Agent Environment, Security, Threat, Risk, and Outcome. And that name tells you everything you need to know about its focus. It's not just thinking about a single app in a box, it's looking at the entire ecosystem where these agents live, work together, and of course create risk.
What makes Maestro so different is that it's built on these core principles that directly plug the holes we were just talking about. It extends the old ways of thinking. It focuses on that whole multi-agent world, and it tackles AI-specific threats head-on. But, maybe its most powerful idea is this concept of a layered security architecture.
Let's see how this actually works. Instead of just trying to, put a bigger lock on the front door, Maestro says you have to secure your AI system like you'd secure a skyscraper. You need security on every single floor, from the foundation all the way up to the penthouse. It breaks the whole system down into 7 distinct layers, and each one has its own unique vulnerabilities.
We're going to start at the very bottom. Layer 1, the foundation model. This is the core large language model, the actual brain of the whole operation. The big threat here is something called an adversarial example. It's basically a cleverly disguised input that's designed to fool the model. Think of it like an optical illusion, but for an AI.
Okay, moving up. Layer 2 is all about data operations. An AI agent is only as smart or as safe as the data it learns from. So what happens if an attacker poisons that data? It's like feeding a self-driving car's AI thousands of pictures where every stop sign is labeled "Go faster." You can corrupt its behavior from the inside out.
Layer 3 brings us to the agent frameworks. These are the toolkits people use to build agents, things like LangChain or AutoGen. And this is a classic supply chain risk. If an attacker can just compromise one popular software library, they could sneak a backdoor into every single agent that gets built with it.
At Layer 4, we've got the nuts and bolts, the deployment infrastructure. This is the cloud server or the container where the agent actually lives and breathes. A classic threat here is just hijacking that container, maybe to mine some crypto, or even worse, to use it as a launchpad for deeper attacks into your network.
Now this one is super subtle but so important. Layer 5 is about how you watch the agent, how you monitor it. If an attacker can mess with your monitoring tools, they can make a malicious agent look like it's doing a perfect job. And if you can't trust your own dashboard, well, you're basically flying blind.
Layer 6 is fascinating because it's the security layer itself. You know, we often use other AIs to monitor for threats, but what happens when the bad guys design attacks specifically to fool your security AI? They can use these adversarial tricks to basically become invisible to the very guard you put on patrol.
And finally, all the way at the top, we have Layer 7, the live agent ecosystem. This is where the agent is out in the wild, interacting with the world. The huge threat here is goal manipulation. Imagine an attacker subtly twisting a trading bot's main goal from maximize profit to maximize profit, but for me, the chaos that could cause is immense.
Okay, so we've got this really powerful 7-layer model. But how do you actually use it? The great thing is that Maestro isn't just theory. It's a super practical process. Let's walk through how you'd actually put it to work.
So applying Maestro is really a continuous 5-step cycle. First, you take your system apart, mapping every piece to one of those 7 layers. Then, you brainstorm all the things that could go wrong in each layer. After that, you assess the risk. Which of these threats are actually dangerous? Based on that, you create a real plan to fix them. And finally, and this is key, you implement those fixes and you continuously monitor, because with AI, the whole landscape is changing by the second. Let's make this super concrete with an example. Say you have a system where a few AI agents need to talk to each other to get a job done. Well, Maestro immediately makes you think about threats like someone attacking the communication channel between them or one agent pretending to be another. The scenario? An attacker slips bad data into that channel. And just like that, the solution becomes obvious. You need to secure the channel, make sure every agent proves its identity, and validate everything that comes through. It gives you a clear path from design to defense.
You know, if there's one single thing to take away from all of this, it's this idea right here. Security in the age of AI is not a one-and-done patch. It's not a finish line you cross. It is a constant, never-ending process of adapting, just like the very AI systems we're trying to protect.
And that really leaves us with this final, crucial question. As these autonomous agents weave themselves deeper and deeper into our lives and our businesses, the real challenge is one of mindset, not just technology. How do we build and manage these things to make sure they stay as powerful collaborators and don't accidentally become our biggest vulnerabilities? That's the core question that a framework like Maestro helps us finally start to answer.